Here we go with session 8 of day 2 of the 2025 RNG Technical Symposium. In this session, we're going to hear from Infinium about their offering that they bring to the biogas space. With that, I'd like to introduce Liz Myers. Liz is the SVP of Strategy and Solutions for Infinium and has been a member of the leadership team since the company's inception in 2020. Infinium offerings include ultra-low carbon synthetic e-fuels, solutions enabling monetization of flare gas and RNG, and patented technology designed to support the rapidly evolving energy industry. With an advanced degree in analytics, Liz brings a data-first approach to partnership development and business growth, and also leads the company's renewable power strategy and implementation. Her professional experience spans energy demand research, price forecasting, and strategy consulting. She helped drive early deals with investment partners, including Amazon, Mitsubishi Heavy Industries, NextEra Energy, and Howard Energy Partners, and she emanates from Sacramento. So with that, a warm welcome for Liz, and you get a quiet standing ovation / golf clap here from everybody who's on mute, Liz. So floor is yours.
Great. Thank you, Paul, and thank you for having me. And for those of you that it's the end of the year day on the East Coast, I appreciate you sticking around to hear about Infinium's offering.
It's our pleasure.
So as Paul mentioned, Infinium is a technology company and a project developer. We have over 15 years of gas conversion solution experience, both in the research and development, as well as commercialization of novel energy solutions. So we do have a low carbon synthetic e-fuel business, as well as what I'll focus on today is a gas to liquids conversion solution with patented technology and platforms designed to scale modularly with feedstock sources. And I can talk a bit about the variety of sizing that we offer in our technology. And Infinium doesn't just develop and license the technology. We have and do deploy projects ourselves. This really allows us to continue to refine the technology and provides a strategic advantage to our customers who are looking to deploy these assets in real world and sometimes challenging conditions as we look at varying types of gas feedstocks, market conditions on power, and the fuel market experience that the team brings. Infinium's backed by highly aligned strategic and financial investors. Some of our largest investors to date are Amazon through their Climate Pledge Fund, NextEra Energy, who's a large renewable power provider here in North America, as well as multiple other international investors who support both financially, but also from a strategic value in the mission of the company. We work closely with other commercial partners on our project development and asset implementation. And most recently, we've brought in Brookfield Asset Management and Breakthrough Energy Catalyst into our project level financing. So we do look closely at structuring the projects and opportunities here that are able to leverage infrastructure investment and grow the platform over time. Infinium has a variety of technology solutions. Here I'm focusing on the main pieces of the technology that apply to biogas to fuels conversion. One is our Infinium Reform, which is an electric steam methane reformer design that effectively operates the same manner as a traditional SMR, but with zero process emissions because of the electric heat in that reactor. And so you're able to reduce the CO2 impact of that reforming process by utilizing electric heat instead of gas for that reforming process. Infinium also has Infinium Synthesize, which is an alternative to Fischer-Tropsch in a direct fuel production process. So as opposed to a traditional FT process that takes syngas and goes into a wax that has to then be hydrocracked and upgraded, we have a chain limiting catalyst and reactor design that has been deployed commercially in GTL assets here in North America that directly produces liquid range fuels. And so that eliminates a operating step reduces the capital expense required and really allows for different scalability to leverage some of these unique gas assets that may be smaller than a full GTL facility would traditionally handle. And outside of its core technology, Infinium does offer integrated solutions for entire end-to-end technology designs and packages for GTL, as well as the e-fuel space, which is CO2 and hydrogen conversion. So a little more into the GTL offering itself. The technology starts with gas and water as feedstocks into the electric steam methane reformer to produce syngas. That syngas then moves through the Infinium liquid fuel production reactors and catalysts and directly produces synthetic fuels on site. Depending on the ultimate desires of the customers and that downstream market, the technology can be factored to monetize sustainable aviation fuel, diesel, naphtha, or chemicals. So we have multiple different designs to look at the different cuts of those products and what the highest net back in the market is and value for the customer that we're deploying for. So feedstocks on this platform include biogas, RNG, stranded natural gas. We've done flare gas applications and other light hydrocarbon streams that can work through this reforming process. Some key process advantages to highlight is that process emission reduction on the SMR to really reduce the carbon footprint of the overall process, as well as I mentioned, the direct fuel production catalyst and reactor designs that's really unique in the industry and allows us to scale this technology in a unique and modular manner. So we are able to look at designs that can handle between 2,000 to 60,000 MCF a day of gas feedstock with varying degrees of product output from 200 barrels a day to 500 barrels per day, converting that natural gas into these high-value liquid transportation fuels. Diving in a little deeper into the fuels themselves and the products that are produced. So these are synthetic transportation fuels. The sustainable aviation fuel produced meets the existing ASTM D7566 specification for synthetic paraffinic kerosene. So no new pathways need to be made for the fuels that we produce. Depending on the feedstock, very good carbon intensity savings and potential premiums paid for customers in decarbonizing this aviation space. And then outside of the carbon emissions, these synthetic fuels do offer improvements when looking at air toxins, reduced particulate matters, and other benefits on the combustion versus a conventional fuel. Similarly, the process can also produce a diesel or a synthetic diesel that meets ASTM D975 specifications. Our facilities to date have produced this. We're producing it now at our Corpus Christi facility, delivering this spec product to customers who are using them in their transportation fleets. As with other synthetic diesel fuels, it's high cetane, has zero sulfur, low lubricity, so very good performance characteristics compared to a conventional diesel as well. There's also a naphtha stream that can come off of, depending on the design and the ultimate end products. This can be used as a gasoline blend stock, though we've found a lot of interest in placing this in the petrochemical market and have deals with companies like Borealis who are taking this product and using it in their naphtha crackers to produce lower carbon polypropylene and move that through the plastic supply chain. So Infinium's unique advantage is not just in the technology, but also in the execution history to date. We've had commercial deployments both on the GTL side and on our e-fuels platform. GTL through licensed partners who have deployed this technology in North America and are now operating the only GTL assets, to our knowledge, in North America at small modular scales. We've also ourselves commercially deployed our e-fuels technology and have the world's first operating facility in Corpus Christi, Texas, producing ultra-low carbon e-fuels for customers both in the transportation and the chemical sector. The company's history really is in R&D and specialty in catalyst and catalyst design. And so we have industry-leading proprietary catalysts that we manufacture and distribute in-house and as part of the licensing package or project deployment package that we work with customers on. Really strong IP and IP quality across multiple geographies internationally, and really a focus on high quality products coming out of the facilities on no matter what gases are deployed upstream of that. And most unique in this industry to date is really our execution experience. So we've owned and operated our facilities that operate our technology. This has allowed us to deploy in real world conditions with real varying degrees of gas concentrations and really understand how the technology performs in those environments. This also allows us to leverage that expertise in services for our licensee customers and support them not only in their technology journey, but also in their execution journey, and have a training facility for operators to really learn how to operate and understand the technology in detail. So wrapping up, ways to work with us today, we have a flexible business model and are interested in, not only technology licensing, but also engaging on interesting projects that we may be able to participate in going forward. So we offer technology license, catalyst license, and supply. We also support proprietary equipment for primarily our reactors that you see here in this picture to the right, as well as engineering services and project development and execution services. So I look forward to hearing from those in the space that are interested in GTL, biogas, and RNG conversion to liquid fuels, and happy to wrap here and take any questions that you have.
Okay, thanks, Liz. Appreciate that. So, good friend is asking, can you tell us about a case study?
Case study, sure. So to date, and I can't talk specific names due to confidentiality, but we have licensed to 2 separate parties on the GTL space who have operated gas to liquids assets using stranded natural gas in 2 cases and flare gas in another case, deploying this technology and converting that to liquid fuels, both here in North America, the United States and in Canada. So we have a number of reference sites that, in deeper diligence, we're happy to go into detail on related to the gas to liquids technology. Separately, we have deployed our e-fuels technology, which shares a lot of the similar flow sheet. Predominantly that direct fuel production, reactor, and catalyst design is the same on both of those. And today we are operating that as Infinium in Corpus Christi, Texas, with continuous operations there, and have that reference case for customers looking to license the technology.
I have a question on the term GTL. So GTL, gas to liquids, which is harder to create, diesel fuel or aviation fuel?
Great question. I'd say they are with our direct fuel production catalyst, getting through that liquid fuel production range to that liquid fuel production range product is equal, and the difference is how you process it after that. So to get the cold flow properties required for aviation fuel, we do use some light isomerization to upgrade that distillate range product into SAF. So there is an extra step when you're adding sustainable aviation fuel as a product cut, as opposed to diesel, where you just have simple distillation after your liquid fuel production reactors.
Okay, so question about your contact information. You'll have that on your slide deck, correct? That's going to be sent around. Is that
Yes, that's correct. And let me put this back up. I didn't make it to my last slide here that
Okay.
also has my email
Well, there
information.
you go. You can screenshot that, folks. Um, what is the ideal scale of a project, and can you further explain your role in development?
Sure. So, scale is your friend in all of these deployments. But we do look at modular designs to be able to look at scales that are about 200 barrels per day of production up to 5,000 barrels per day of production. And in gas terms, that you'd be somewhere between 2,000 MCF a day to 60,000 MCF a day. So depending on the type of source that you're looking at, that's a good range that would have what we believe is comfortable economics. We have deployed assets at 50 barrels per day on gas to liquids, and depending on the input prices of that gas can also work economically, but would have to look at the specifics as you get into smaller scale units.
How different do you think your technology is relative to legacy Centrolium's Fischer-Tropsch process?
I am not familiar with Centrolium's process, but I can speak to how it's different from traditional GTL that's operated by some of the majors like Shell, Chevron, Sasol. So the main difference is that we have this chain limiting catalyst that allows us to produce directly liquid range products. So when the syngas moves into our liquid fuel production reactors and gray cat catalyst, the chain length stops its growth in that distillate range of product. So while we do still get a distribution curve that includes some light ends and some heavy ends, the bulk of the production really lies in that distillate range. So the advantage there is really skipping the hydrocracking and refining of a petroleum or a Fischer-Tropsch paraffin wax that is typical of conventional FT type processes. So rather than having to do that hydrocracking upgrade, we just directly produce into that liquid range of product.
Okay. So we're people that speak a different terminology in our biogas world than liquid fuels. So 200 barrels a day was kind of the low end, and you equated that to 2,000 MCF per day. Your unit M is 1,000, right? So 2
Correct.
million cubic feet a day.
Yes.
So if I do that math, 2 million cubic feet a day, 200 barrels you're saying there's about energy equivalent to 10,000 cubic feet of gas in 200 barrel and per barrel. 10,000 cubic feet of gas in a barrel of liquid petroleum, I think is maybe that math doesn't, maybe we're not on the same page, but you said again, 200 barrels a day is 2,000 MCF a day.
Correct.
Okay. Then we can do the math from there. Okay. Is it easy to toggle between SAF production mode and diesel mode?
Technically, yes. I'd say from a capital perspective, you likely wouldn't want to add the extra capital for isomerization upgrading if you weren't going to commit to that capital being leveraged to produce the sustainable aviation fuel. So it would be less of a technical question and more of an economic question when you looked at the details of the model.
Isomerization, another new word for us. So isomerization, you're building a polymer, so the SAF molecule is a bigger molecule than the diesel molecule. Is that kind of what I'm gathering?
Yeah, and what it really does is it transforms the molecule into a different isomer so that you're meeting the cold flow properties that are required for sustainable aviation fuel, or aviation fuel in general, which are much stricter because of how cold the air is when you're flying a plane.
Okay.
In simple terms.
Learn something new every day. All right. Where has the Infinium Reform TM been deployed and at what scale?
So the Infinium reform is currently being deployed and at our second asset, project Roadrunner in West Texas. I can't publicly disclose the scale, but if there's interest in that platform and that technology, I'd be happy to take that offline.
Question, maybe we've answered this, so let's try it again. What is the smallest size in standard cubic feet per day? I'm assuming we're talking about biogas here. What is the smallest size in SCF per day that is economical for the technology based on your past studies? Is this your 200 barrel a day answer?
That's correct.
Yeah,
That's
okay.
where we'd want to focus. Now, again, there's technically you can go lower, you lose the economies of scale. So while we'd be happy to explore that with folks that are looking at smaller scale units, it really becomes an economic question at that point, versus a technical question.
So I'm just running some numbers here. 2 million cubic feet a day divided by 1440 minutes per day. I'm coming up with 1,389 SCFM of, that would be biomethane. That would be biomethane. So if I divide that by 0.6 to get the biogas, that's 2,300 SCFM of biogas. So, you know, in our world, we do digesters or landfill gas, and then we upgrade it and we would get the project RNG. So do you have any sense of like what purity RNG biomethane you would require, 99% or something, or?
There's a lot of cleanup that we can do on the facilities. We've done this for a variety of different gas types, so it would really be something we'd want to look specifically at that gas and see what cleanup would be required to enter our production facility.
So let's talk about financing. So if we had an opportunity, we wanted to look at the Infinium offering, we've got the feedstock digester gas upgrading part. On the GTL part, do you bring the financing for that, or is that outside, or are you just selling licenses to somebody else?
We can look at a variety of different opportunities. I'd say at this stage, we're more likely to be in the licensing space than to bring the financing ourselves, though we do have a number of parties and investors who are very interested in these types of projects. So we can certainly support the engagement on that side if there was a project that was economically interesting for our group of investors.
So this question of the budget cost for your smallest system, is that something you're comfortable answering or not so much?
Not here, but happy to engage in detailed conversations separately on costs.
Well done, well done. Did you mention the catalyst you use to hydrogenate CO, if I missed it, cobalt or nickel molybdenum?
So the catalyst is, very much our proprietary and trade secret. So we don't disclose what is in them, but as a principle for the company, all of the catalysts that we manufacture are, have commercial viability in mind, both from a cost perspective and an availability of the catalyst components themselves.
Okay. No one's asked me about offtake yet. I'm waiting for someone to ask about offtake, but I won't ask if nobody's asking me. So let's see, Liz, can you clarify that the Infinium reformer can take biogas in addition to RNG, so CO2 and CH4 in addition to just CH4 only?
Yes, that is correct.
Okay. So you're not looking for RNG per se. You can take biogas.
You can take biogas as well. So I think what we'd look at is, any other contaminants in there. And, for catalyst processes, the bad actors are things like high sulfur levels and things of that nature. But, again, we can look at a case-by-case basis, and there's plenty of low-cost cleanup options available depending on the purity of that feedstock.
Okay. Okay.
And I did see, if you don't mind me jumping in, there's the separate webinar chat did have a question about offtake, so I'm happy to dive into
Oh,
that.
okay.
We have signed, and these are public deals. American Airlines has a deal, and this is on the e-fuel side, so it's not with a RNG or biogas feed, but instead CO2 and hydrogen feed to fuels. But again, same back end on the fuel production system. We have signed commercial long-term agreements with American Airlines and IAG, who's the owner of British Airways, who's taking that fuel into the UK market.
All right. I think we've gotten the ball rolling here. So the question board is clear. So good to meet you, Liz. Thank you. Welcome to the biogas world. And we hope we can do some work with you guys. And let's just see, did something else come in? Any examples of commercial airlines that are off takers for any Infinium projects?
We just covered that one, so I jumped in
Oh,
there.
sorry, sorry, sorry,
American
sorry.
Airlines and IAG, no worries.
My mind was sideways. Are you offering systems to convert CO2 into electromethane?
We do have a technology that does that. It is earlier stage, and we'd want to look carefully at the specific use case and application, but there has been an increased interest in that natural gas, if you will, in the market, potentially for export as LNG. So yes, though not at the same commercial scales that we've operated our GTL and our e-fuels technology today.
Okay. Okay, I think we're a wrap, unless anybody has anything last minute. Again, thank you, Liz. Good to meet you. And thanks to everybody that stuck with us till the end here for the full RNG symposium. Day 2 is adjourned. The symposium is adjourned. And so, Liz, we'll catch you later. And all the attendees, thanks for joining us.